Hello, Algebra 2 folks. Today we're going to be talking about adding and subtracting rational expressions, and you're going to need your notes and possibly a calculator, a pen and pencil, the usual things. So before we can start adding and subtracting rational expressions, let's review how to add and subtract regular fractions. When we add and subtract regular fractions, the goal is to have a common denominator. So in your foldable, when it says, how do I add or subtract expressions, one of your bullet points should be this common denominator. So make sure you write common denominators in the top half of your flap of your foldable. And then we also can do this mini example on the top flap of your foldable. So when we say common denominators in these two fractions, our common denominator is 6, and 9 plus 5 would be 14, all divided by 6. And we could probably simplify that. We could take a 2 out of the top and a 2 out of the bottom to be 7 over 3. Okay, so if we think about what we're actually doing when we're adding and subtracting, like terms, okay? So when we talk about that, when we talk about like terms, like in this first equation, we have 3 cows plus 4 cows to give us 7 cows. But when we have our second equation, we have 2 cows plus 3 ducks. Well, those aren't like terms, or they're not like things, so we actually can't simplify it into anything simpler. It's just 2 cows and 3 ducks. So when we're coming to finding common denominators and then adding what's in the top of our numerators, remember combining like terms. That's the whole point of this slide. So you do not need to write this down, but we need to always remember how to combine like terms when we're adding and subtracting with algebra. So the last bullet that should go, we already have common denominators or like denominators on the top half of our foldable. Now we need to say simply add or subtract their numerators, and make sure your final answer is simplified. So remember that we're being slash happy when appropriate with the appropriate factors and making sure that we can simplify the expression overall in the end. So make sure you get this, what's written in maroon and red, on the top half of your foldable. So for number 1, we already have like denominators, 4x and 4x. They're already common, so all we have to do is add the top. So 7 plus 10 is 17 all over 4x, and we can't simplify 17 over 4, so that is actually my final answer. That's as good as it's going to get. On the next example, example number 2, we're all over a common denominator of x minus 5, and in my numerator I have 10x minus 15. But 10x and 15 aren't like terms, so all we can do is say 10x minus 15 all over x minus 5. But am I done? Maybe we can divide out something like we've been doing. Remember, that last step is simplifying the expression. So 10 and 15 have a common factor of 5. So if I take out my common factor of 5, I'm left with 2x minus 3 all over x minus 5. Oh, I thought maybe I could have factored out something so that I could slash x minus 5 over x minus 5, but I can't. So yes, 10x minus 15 is my final answer all over x minus 5. Okay, number 3. So we have x squared minus, remember this is a minus, the whole expression 12 minus x, all over our common denominator of x squared minus 3x minus 28. So if we distribute this negative, we get a negative 12 and a plus x. So I'm going to rewrite that in standard form. So I have x squared plus x minus 12. I distributed that negative and wrote it in standard form all in one step, all over x squared minus 3x minus 28. Before we circle this as our final answer, we should make sure that we can't reduce it any further. So let's factor the top and factor the bottom. So my top, I have x times x to give me to x squared, two numbers that multiply to 12 and add to 1, so that's going to be 4 and 3. We want to keep the 4 positive and the 3 negative. And then on our denominator, x times x gets me back to x squared. Now we need numbers that multiply to 28 and add or subtract 3. Well, that's going to be 7 and 4. but we want to keep the 7 negative and the 4 positive in order to get back to a negative 3. So indeed, I can slash x plus 4. So my reduced answer is x minus 3 all over x minus 7. So that's actually my final answer, not this guy, because we needed to simplify our final answer. So we factored and then simplified. All right, number 4. So now we have x squared plus x all over our common denominator of 2x squared plus 3x plus 1. So so that's my answer, but we need to double check if we can simplify it any further. So we're going to have to factor and see if we can slash anything. So I can take an x out of the top, getting me with x plus 1 all over. Now I'm going to have to use trinomial methods. So I'm going to have 2x and x to get to 2x squared. Well, factors of 1 are only 1 and 1. And does that actually get me to 3x in the middle? Well, 2x times 1 is 2x, plus 1 is indeed 3x for the middle. So look at that, I can slash my x plus 1s. So my final answer is x all over 2x plus 1. So today was more so reviewing how to combine like terms and how to simplify our rational expressions so that we can have our answers in most simplest form. Thank you for taking good notes, and I'll see you soon.